Hey everyone, welcome back to my Python tutorial. In this tutorial, I am going to show you how to create a temperature converter GUI program using Python's Tkinter module. Before proceeding further, please be sure to drop a like on this video, and subscribe to my channel, for more such tutorials. So, without any further ado, let's jump into the tutorial. Open your IDE. Then, you are good to follow along. Let's import the Tkinter library. Import Tkinter as TK. Import the Tkinter's TTK module, as TTK. Let's create a root window, by initializing an instance of TK. Set the title of window to temperature converter. We'll set the dimensions of window to 900 by 510, using the geometry method. Please note that this is going to be a static app, meaning all the widths, heights, and placements will only work for current dimensions. If you want to use other dimensions, you need to change the x and y coordinates, widths, and heights, relative to new dimensions. You can see the image that shows what you need to change everywhere as required. If you want to skip this hassle, you can download the source code for the dynamic app on my Patreon for $1. Coming back to the code, we'll disable resizing of the window, using resizable method. Let's declare some constants for the color palette of the app. I am using a dark gray color as primary color for the app, while a green color as secondary color. For the shade of primary color, I will be using a lighter version of primary color itself, which will be used as background color for the input box. Similarly, for the shade of secondary color, I will be using a dark version of secondary color, which will be shown on button's background, on button click. Let's write a getFont function, which will generate a font of given size, and weight. We'll default the size parameter to 9, and bold parameter to false. Return a tuple containing the font name as TK default font, font size as the size parameter, and weight to bold, if the bold parameter is set to true, else normal. Let's define a validate function, which will control what is being entered into the input box. It will take a value as argument, which the input will have, if the change is allowed. We'll first check if the value is empty, so that the user will be able to clear all the text in the input box. Next, we'll check if the last character is digit or not, using isDigit method of the string. Also, be sure to first check if the string is empty, using OR operator. This is to prevent any index errors, which the latter expression would raise, if the string was empty. We'll allow the minus sign to be inserted only at beginning, by checking if the value is a hyphen, and total length of entered value is 1, that is the minus is the first character. We'll allow only one decimal point, by checking if decimals count is 1. Lastly, we'll return the results by using OR operator on all the tests. We'll declare calcFunc dictionary, which will be containing functions to convert the temperature from one unit to another. The keys will consist of 2 characters, with first character being the unit, from which the temperature has to be converted, and second character being the unit, to which the temperature has to be converted. We'll use lambda functions, to create inline functions, to convert the value between the units. To convert Celsius to Fahrenheit, we'll multiply the Celsius value by 9 by 5, and add 32 to it. To convert Celsius to Kelvin, we'll add 273.15 to the Celsius value. To convert Fahrenheit to Celsius, we'll subtract 32 from Fahrenheit value, and multiply it by 5 by 9. To convert Kelvin to Celsius, we will subtract 273.15 from the Kelvin value. Now, to convert Fahrenheit to Kelvin, we'll first convert the Fahrenheit value to Celsius, and then convert the Celsius value to Kelvin. Similarly, to convert Kelvin to Fahrenheit, we'll first convert the Kelvin value to Celsius, and then convert the Celsius value to Fahrenheit. We will now write a convert function that will perform the conversion. It will take input entry widget from unit, target unit, and result string variables as arguments. Let's get the first letters of both the units. You need to call the get method on the string var to get its value, and then convert it to lowercase, since our keys in calcFunc are also in lowercase. Since the toUnit will have the complete name of the unit, we will only use its first character. Now, we will try to parse the input value to a float inside a try block. If it raises a value error, which means the entered input is invalid, we'll update the value of result variable to display an error. Also, do an empty return to stop the further execution of the function. If both the fromUnit and toUnit are same, we will set the res variable to the parsed value itself. Else, we will concatenate both the units to call the desired function from the calcFunc dictionary. Now, if the target unit is not Kelvin, we will set the result variable to the res variable, by rounding it up to 2 decimal places, along with the degree symbol and unit. Else, we'll do the same, but without the degree symbol. It is because Kelvin is an absolute temperature scale. So measurements made using it does not have degree. Now, we will register our validate function in the root window, so we can use it for validate command parameter of entry widget. Now, we'll create a border around our left frame. Create a Tkinter frame, with parent window as root. Set the background color to the secondary color. Set width and height to 450 and 510 respectively. Place the border frame at 0, 0 coordinates. Let's create a left frame, with its parent as border frame. Set the background color to the primary color. Since I want a border width of 5 pixels, I'll subtract 2 times the border width from border frame's width and height. The resulting values will be width and height of the left frame. Place the left frame at 5,5 coordinate. Create a Tkinter label, with left frame as parent. We'll set its text to enter temperature. Set its PG to primary color, and FG to secondary color. For the font, call the getFont function, with size as 16, and bold parameter set to true. Place the label at 30,50 coordinate. Similarly, create another label, with text as degree. Change the font size to 9 for this label. We'll place this label above the entry widget. Place the label at 30,120 coordinate. Now, create an entry widget, with parent as left frame. Set its PG to the shade of primary color. Set FG to white. Set insert background to white, which will change the blinking caret's color. Set border width to 5, which will create an internal padding, when paired with flat relief. Set validate command to a tuple, containing the registered validate function, and %p substitution code. Set validate to key, since we want to call this command on key press. Place the widget at 30,160 coordinate. Also, set its width to 265, and height to 42. Let's create a Tkinter string var to hold the unit for the input value. We will default the unit var to C, which is for Celsius. Similarly, create another string var, and set its value to Fahrenheit. This var will hold the target unit for conversion. Now, we'll use the TTK module to create custom styles for our option menu widget. Create a new instance of TTK style. Use the configure method to customize the style. We'll name the style unit.tMenuButton, where unit is the new name of the style, while tMenuButton is style name for option menu widget. Set the background to secondary color. Also set the relief to flat. Similarly, we will name the style for target unit option menu as convert to .tMenuButton. Set its relief to flat. Set its background to shade of primary color. Set its foreground to white. Set his width to 320. Now, create a TTK's option menu widget, with parent as left frame. Pass the unit var string variable as the second argument. Set the C as default value. Pass C, F, K as options. Set the style parameter to unit.tMenuButton, which is the name of our custom style. Place the menu at 300, 160 coordinate. Also set its width to 50, and height to 42. Now, create a Tkinter label, with parent as left frame. Set its text to convert to. Set its PG to primary color. Set its FG to secondary color. Call the getFont function to use a font with size 9. Place the label at 30,280 coordinate. Let's create a TTK option menu, with parent as left frame. Pass the convert var string variable as second argument. Default the menu's value to Fahrenheit. Pass Celsius, Fahrenheit, and Kelvin as options. Set its style to convert to .t menu button. Place the menu at 30,320 coordinate. Set its width to 320, and height to 42. Let's create a Tkinter button, which will convert the temperature, upon click. Set its text to convert. Set its BG to secondary color. Set its FG to primary color. Set its font size to 12, using the getFont function. Set its relief to flat. Set its active background to the shade of secondary color. Set his border width to 0. Place the button at 150,420 coordinate. Set its width to 140, and height to 40. Now, we will write the code for right frame. Create a Tkinter frame, with root as parent. Set its BG to secondary color. Set its width to 450, and height to 510. Place the frame at 450,0 coordinate. Create a string var, which would hold the result of conversion. Set its value to empty string. Create a Tkinter label, with right frame as its parent. Set its text variable to the previously created string var. Set its BG to secondary color. Set its FG to primary color. For the font, call the getFont function, with size 64, and bold parameter set to true. We will place this label in such a way that it is centered, relative to the black frame. Set the rel(x) to 0.5, and rel(y) to 0.4901. I got these values by performing the math. Set the label's anchor to center, by using Tkinter's center constant. Let's configure the convert button, to add a command to it. We will use a lambda function, so that we can pass arguments to the convert function. Pass the input entry, unit var, convert var, and result var to it. Lastly, call the roots main loop method, to start our Tkinter app. Let's see our program in action. As you can see, it is looking great, and working as expected. So, that's all for today. Hope you would have enjoyed the tutorial. The entire source code for this project is available on my Patreon, which you could download for only $1. Please be sure to drop a like on this video, and subscribe to my channel for more such tutorials. I will meet you next time. Till then, good luck and peace.